How are you guys? In this video, we have reached lecture 18 of the Algebra Course lectures. This is about distance and midpoint formulas. So again, this is lecture 18. If you want to see the other lectures, please go to the playlist called Algebra Course Lectures. Let's start. Now, the objective of this lecture, there are three main ideas. We need to explain the coordinate plane, the distance formula, and the midpoint formula with other examples. In this slide, there are many words you have to know. If you are not familiar with these, the coordinate plane, we have x-axis here, we have y-axis, we have four quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, we have all the x and y values and the ordered pair, x, y, all positive here. In quadrant 2, every point has x negative, y positive. See the y positive here, x negative. Every point in quadrant 3, we have x negative, y negative. In quadrant 4, we have x positive and y negative. The point of intersection of the x-axis and the y-axis, we call it the origin. What else? P, any point in any place, we call it ordered pair. A is the x coordinate and y is the y coordinate. Why we call it ordered pair? Because we have pair, which is 2. Ordered means the first value is the x and the second value is the y. It should be in sequence or in order. Simple example, let's plot some points here, A, B, C, D, E, F, on a rectangular coordinate system. Just see where the points are located. Just an example here, we see point A, 4, 5, it is located in quadrant 1. D, 3 minus 5, you can see it is in quadrant 4. Just take the x and the y, ordered pair for every point, and see the location. See A, 4, x is 4, y is 5. So you can see that in quadrant 1. Just an example here, I take D, 3, 3. So D, 3 in the positive x, negative y, 5. So that's a point D here. Point E, let's see point E. Point E, 4, 0, x is 4, 0 is y, so it is E lies on the x-axis, and F is 0, 2. 0, 2. So F lies on the y-axis because x is 0 and y is 2. Now another example, we need here to sketch a region and we need to describe it. The set of all points, this is a set here, x, y, the set of all points such that x greater than or equal to 0. Second one, the set x, y, all points such that y greater than minus 1 less than 1. See, we can see in the first one, only the condition on the x, so we can see now the region, and here only the condition on the y. We can have conditions on x and y. Let's see the first one. The first one, x greater than or equal to 0. See, any point in quadrant 1, x is greater than 0. Any point on the x-axis here, x is equal to 0. Positive x, also any point in quadrant 4. So we say here, set of all points x, y that lie on y-axis or to the right of the y-axis in quadrants 1 and 4. See, there is no condition on the y, just notice here, there is no condition. We have greater than or equal, so we put a solid line. If we have less than or greater than, we put dashed lines. Points on the y-axis here, see the y-axis, the blue, it's a solid line, so the points are included since we have greater than or equal. Now the second one says y equals 1, greater than minus 1, and less than 1. Look at the lines here, y equals 1. See, this is line y equals 1. It's dashed. See, dashed because we have less than and greater than. No equal. So that's a dash. Greater than minus 1, less than the 1. So it is the strip here between minus 1 and 1. So that's the region, set of all points that lie between the lines y equals 1, y equals minus 1. Let me just remind you here with the Pythagorean theorem, which says if we have a right triangle, let's say the 90 degrees, right triangle means 90 degrees, one angle is 90 degrees. Suppose this 90 degrees is at C, so we have the side or the leg facing the 90, we call it hypotenuse. See this one, let's call it small c. So c squared is equal a squared plus b squared. See, A is the small side and B is this other small side. C is the hypotenuse facing the 90. So A squared plus B squared is equal to C squared. Just to mention that A by itself, we call it a vertex. If we take all the points A, B, and C, we call them vertices. Now, the distance formula, one of the important formulas here in this lecture, distance formula. The distance formula between any 2 points, just take any 2 points, x1, y1, see, x1, y1, A, point A, and we need the distance to be x2, y2. We need D of AB. So we can make a triangle here, 90 degrees at C, and then use the Pythagorean theorem, this one squared is equal to this one squared plus this one squared. So the distance becomes, the formula that we have to remember is the square root of x2 minus x1. x2 is the x coordinate in the second point, x2 minus x1 here in this first point squared plus y2 minus y1 all squared. Now you can start with B or you can start with A. Anyway, you have to square it and then you add under the square root. Let's see two simple examples here. Let's find the distance between the points P and Q. P is minus 4, 5, Q is 3, minus 2. Easy, we will do that now. And then we have another distance between E and F where we have square root of 2, something square root of 5. Just a little harder numbers. Just write the given here, P minus 4, 5, Q 3 minus 2. I can call this one x1, y1. Then this will be x2, y2. I can call this one x2, y2 and this one x1, y1. Same answer. So let's go by this way. So we need the distance. So x2 minus x1. x2, 3 minus 4. Now, the only mistake you can do here, if you don't take care of the minuses, and then y2 is minus 2 by itself, minus the y1. y1 is positive 5, so I write minus from the formula and 5. Now, 3 minus 4, this one becomes plus 4, correct? 3 minus 4, plus 4. So that's 7 squared, 49. Minus 2 minus 5 is minus 7. When you square it, 49. Now you have to add inside here. You cannot say, this is a big mistake if you say square root of 49, square root of 49. That's a big mistake. You add 98. 98, you break it down into 2 times 49. Then you can split because we have multiplication. You cannot do that if we have addition. So take 7 out. 7 square root of 2. That's the simple answer for the distance between P and Q. I advise you here to try yourself. Take E and F, write it down, pause the video a little, and then try to find the distance between E and F. Please write E, write F, then I will leave this slide for you so that you can apply on E and F. You can see the formula, you can see the numbers, and then you can check your answer in the next slide. When you are ready, we can go. Let's try now. The answer you should get is square root of 133. I hope you get that answer. Let's see all together. So this is a point E. This is a point F. Let's call the first one x1, y1. Second one x2, y2. Just apply the formula. So x2 square root of 2 minus the first one plus squared. Remember squared. y2 minus square root of 5 minus 4 square root of 5. Now here you can add. So this is a minus 2. So this is like when you have m minus 3m or x minus 3x. It's minus 2 square root of 2. Remember that. Okay, squared. When you square it, you get 8. Because minus times minus is plus. 2 times 2 is 4. Square root of 2 is only 2. And this one minus 5 square root of 5 is 125. When you add, square root of 133, and you cannot simplify that one. Now let's look at a very nice example. We call it here example 4. This is an exam type. See, usually you have such questions, maybe similar in some of the exams if you have a math exam. Find x. So we need to find the number x. If the distance between the points A and B is equal to 12 minus x. See, x is missing here. Find x. I gave you the point A, 3x minus 3x. The point B, minus x minus 6x. And I gave you condition, x should be negative. So at least you know when you find x is a negative number. Maybe minus 5, maybe minus 11, maybe minus 23, maybe minus 100, maybe minus half. But if you get, let's say x equals 7, for sure there is something wrong. So what do we have in the question? We have condition on the x, we have the point A and the point B, we have the distance here. So for sure here we have to use the formula. So x1, y1, x2, y2, use the formula, put then this is equal 12 minus x. Okay, now let's see this one, x1, y1, x2, y2. Very nice question. There is a little idea here inside. Let's find the distance. x2, you see x2 here minus x minus 3x squared. And then y2, minus 6x minus becomes plus. Now minus x minus 3x minus 4x squared, see 16x squared. Minus 6x plus 3x is minus 3x. You square it, that's 9x squared. See, add here inside, you get 25x squared. That's the trick in the question. You have square root of 25x squared. If you write the answer 5x, that's wrong. That's the whole trick. So you should write the answer 5 absolute value of x. And we know x is negative given in the condition. It's written here, you see that one? So when x is negative, the absolute value is minus x, because we know x is negative by itself. If you have to put the minus in the condition here. You can see Algebra Course, lecture 1 on this. You can see absolute value, the conditions. So this will be minus 5x. Now the distance we have is 12 minus x. So I can write the distance we found minus 5x is equal to 12 minus x. Say take the minus on the other side, becomes minus 4x equals 12. Divide by minus 4, x will be minus 3 is the answer. And the nice color and the nice answer here. So x will be minus 3. Okay, the midpoint formula. The midpoint formula, we have a line segment, and there are 2 points there, A and B, or x1, y1, x2, y2. If I need the midpoint formula, the midpoint formula means the point in the middle. The point in the middle. Some students, they have a confusion between midpoint and half the distance. Like if I give you point x1, y1, x2, y2, if I say find the midpoint, I have seen some students, they find the distance and they divide by 2. That's completely wrong. Because if you find the distance, divide by 2, this is halfway. But in the midpoint, I need the point. What is the point? What are the coordinates in the middle? So it's x1 plus x2 over 2, y1 plus y2 over 2. Just a quick, simple example here. If we have a 15, 14, that's a point. Another point, 7, 12. If I say find the midpoint of the AB, so I take 15 and 7, I add, see, addition here. There's no minus in the formula, divide by 2. So 22 over 2 is 11. 14 is y1, y2, 12 over 2. 26 over 2 is 13. So 11, 13 is the point in the middle. Let's see some questions about midpoint formula. Oh, nice question maybe. Find the value of AB. So we need A, we need B, then we multiply them. If the point minus 6, 6 is the midpoint of these 2 points, 2A plus 3, 2B minus 8, 3A, 3B. See, this is like a little twist here. I gave you the midpoint, minus 6, 6. I gave you 2 points here with some variables A and B. So I want you to find A, find B, then multiply them to get the value required in this question. So you can make here a little sketch or a little diagram. Always, I will advise you later to do these. Any question you cannot understand, try to read it 1 time or 2 times, make a little sketch. By sketch, I mean put a line, put a triangle, put a rectangle, put a square, sketch it. If you have a circle also. Let's see. So this one is the point. This one is another point. We have minus 6, 6 in the middle. See here we say since minus 6, 6 is the midpoint, so I can use this formula. So this is 2A plus 3. You see 2A plus 3 and then 3A. I add over 2. Y1 here, 2B minus 8, 3B. I add over 2. This is exactly, it's given minus 6, 6. So minus 6 is the first x coordinate here, you see? 2A, 3A, 5A plus 3 over 2. That's minus 6. 6 is the second here, coordinate on the y coordinate. So 2B, 3B becomes here 5B minus 8 over 2. See, I created here 2 simple equations because these are the same point. If this is the same point, a point equal a point, x will be the x, y will be the y. So I can make simple equation here. I'll find cross multiply here. 5a plus 3 is equal minus 12. A will be minus 3. Here we cross multiply. 5b minus 8 is equal 12. Then b will be 4. Now what do we need? Multiply a and b. So the answer minus 12. Nice question. Another one on the midpoint, please. Find the coordinates of the other endpoint Q of a segment with one endpoint P minus 612 and the midpoint M 8 minus 2. Now, I gave you 1 point on the endpoint on the line segment P. Find the other point Q if the midpoint capital M is 8 minus 2. Can you figure out the coordinates of the point Q? Make a little sketch. See, M is 8 minus 2 given. We need Q. So I say let Q be xy. Just to make it simple. P we know is minus 612. You see from the question here. P minus 612. M is 8 minus 2. So I take these given. And then I write the formula, same formula, midpoint is this. Then I take the midpoint between P and Q, see? So this is P and Q. I add these x's over 2, I add these y's. Remember, there's a minus from the question, it's -6 here, but I add. This one is equal m, 8 and -2. So this point is equal this point, which means this is the x is equal the x, which is 8. This is the y, 12 plus y over 2 is equal to -2. So I make also two simple equations. X will be 22 here, and y will be, you can figure out, simple equation, -16. That's the point Q here on the other end point. Now this one is very nice, actually. Find K. Where is K? Where is K? Here, you see the point B, K is 6. Find the K. I give you D, a point 0.5 is 5 units from the midpoint of the line segment joining A and B. So there is a line segment A and B, and there is a midpoint of A and B. From the midpoint to another point D, this is D is another point there somewhere. The distance between this D and the midpoint here in the middle, we can call it maybe M, is 5 units. 5 units means only 5. 5 units, it can be 5 centimeters, 5 inches, 5 feet. So when you say 5 units, just take the number 5. So units means there is a distance for the unit. Look at this nice sketch here. Nice sketch. See, I make a sketch, and this is half of the solution here. You can see the solution in the next slide. Because I advise you to make a sketch. If you cannot understand the question, even if you understand it. See, I have A, I have B, easy to visualize. There is an M, point in the middle. From this M, there is another point. It can be there, it can be there, it can be there. We don't care. D is another point somewhere. The distance from D to M is 5. So that means in this question, you have to use the distance formula, you have to use the midpoint formula, everything we have learned in lecture 18. So D is 0.5, leave it. Distance between D and M is equal to 5. A is 0 minus 2, B, K, and 6. Let M be the midpoint here of A and B. So I can go and find M. See, to find M, just use A and B. Leave now D, we will use it later. So find the midpoint M, capital M. This one add 0 and K over 2, minus 2 and 6 over 2. Let's continue on the next slide. You can pause the video here, please, and try yourself, if you understood what I said, in the midpoint, the distance, and try to find K. What is K? Now, just to show you what is K, K will be plus or minus 8. So there are two values for K. Now, as I mentioned, let's find capital M. X1 plus X2 over 2. So this will be K plus 0 over 2. Y1 plus Y2 over 2. So minus 2, 6. 4 over 2 is 2. So K over 2, 2 is the M. It is M. So I found now the distance between D, 0, 5, and M. So X2 minus X1. So now I take only D and M. Okay, so K over 2 minus 0, the squared. So K squared over 4. Y2 is 5 minus 2. See, 5 minus 2 squared, 3, 9 here. Equals 5. 5 from the question. Square now, square both sides. BS, square both sides. So K squared over 4 plus 9 is equal to 25. You can multiply by 4. See, multiply by 4, you get K squared, or you can take 9 on the other side, then multiply by 4. If you multiply by 4, you get K squared. This was 36, this is 100. So K squared will be 64. When you take the square root, K will be plus or minus 8. There are two values for K. Now, the lecture is finished. when we finish the lecture, I will leave some questions. I call them all the exam questions. You can call them practice. You can call them extra questions. You can call them exercises or anything you like. Nice questions maybe. So this is question number one. Let's go by all the exam questions. Number one, use this and find it. And then all the exam question number two, I give you 3 points. Are these the vertices of a right triangle? Nice question. And that's all the exam question number three about midpoint. Question number four, question number five, you can check. This is the distance, find small b. See, find the value of the b. You can try. I will tell you what to do now. This is all the exam question number 6. Find the median. I give you the definition of the median. What is a median? And then all the exam question number 7. Sketch this region and tell me which quadrants. And then here I put the answers. Now that's the first surprise. So I put the answer only for question number 1, question number 2, question number 3, question number 4, question number 5, 6, and 7. If you need, please try them. Because when you take a lecture, you have to try to see if you understood the lecture, if you can do more questions by yourself. That's the aim of the lecture. So the complete solution of these 7 questions, these are 7, you can see them on the video on all exams questions, distance and midpoint. So it will be there in the playlist. You can check it and you will find all the details after you try them, please. Now, thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Just to remind you, this is lecture number 18 in the algebra course. Thank you very much.